Hello, welcome to my channel. In this video, I'll be talking about empirical and molecular formulas. Usually, the compounds are represented by chemical formula in the form of X, Y, Z, where X, Y, and Z stands for the symbol for the elements that make up the compound, and the subscript A, B, C stands for the mole ratio in which they are combined. For example, H2O, this stands for water, okay? And H2SO4 stands for sulfate 6 acid. So this is how compounds are represented. There are two types of chemical formula. There are three types of chemical formula in chemistry. The first one is empirical formula, which shows the simplest whole number ratio of atoms. That is, it shows the simplest ratio in which atom of elements combine to form a compound, while molecular formula show the actual number of atoms in a molecule. Example, for hydrogen peroxide, the empirical formula is HO, which is ratio 1 to 1. But the molecular formula, which is the actual number of atoms that they are combined, is H2O2, which is 2 ratio 2. This is the actual number of atoms that are combined together to form hydrogen peroxide, while this is their simplest ratio. Okay. Structural formula depicts how atoms are arranged in a molecule. In this lecture, we'll be concentrating on these two formulas, as structural formula is more relevant in organic chemistry and some other inorganic chemistry. Now, let's talk about how to calculate the empirical formula of a chemical compound. These are the steps listed here. From this question, we are going to apply these steps and see how we calculate the empirical formula of this chemical compound. Okay. The question is that, say a compound contains 40% of carbon, 60.67% of hydrogen, and 53.33% of oxygen by mass. Find its empirical formula. Step number one is to find the mole ratio of elements in the compound. How do you find the mole ratio? Number one is to find the mole of the compound. We have three elements in this compound, which is carbon, hydrogen, and oxygen. They said carbon is 40.0, hydrogen is 6.67, and oxygen is 53.33. Okay, this question can come in two forms. This is the first form that it can come. It can come in which they will give the percentage composition of each of the elements. Another way it can come is that they will give the mass for each element in the compound, whichever way it comes. Whatever is given is taken as a mass. And if you can recall, mole is equals to mass over molar mass. Okay? And in this case, the molar mass will be the relative atomic mass, relative atomic mass of the elements that make up the compound. Okay? Now, the percentage is already written. We are going to divide it by the relative atomic mass of each of the elements. For carbon is 12, for hydrogen is 1, and for oxygen is what? Is 16. So let's use our calculator to evaluate this. Now for carbon, 40 divided by 12 is equals to, this is 3.3. For hydrogen, that is 6.67. And for oxygen, that is 53.3 divided by 16 is equals to, which is 3.3. Okay, so we've s- we've already find the mole ratio of the elements. The second step, we simplify to the smallest whole number. And the third, the first, we find the mole ratio of the elements. Okay, we simplify it to the smallest whole numbers, and we already convert the mass percentage to moles, which we did here. Okay, now the next step is, we've done this. The next step is divide by the smallest number of the moles. The smallest number of the moles here is 3.3. So if we divide by 3.3, divide this one by 3.3, and divide this one by 3.3. So this one will be 1, this one will be 2, and this one will be 1. So the next thing is to adjust to whole number if necessary. In this case, it is not really necessary because all of them are in whole number. So it means that carbon 1 combined with hydrogen 2 and oxygen 1. So the empirical formula of this compound is CH2O. Don't forget that in chemical formula, you don't need to write 1 there. So that's why it will be this. Okay? So this is how you will be calculating the empirical formula of a compound. Now, how to calculate the molecular formula? Usually, this is steps listed here. Number one is to determine the empirical formula of the compound, which we have done. They said the molar mass of the compound in previous example is 180 gram per mole. Find the molecular formula. We already know the empirical formula of the compound in the previous example, right? Which is CH2O. Okay. Now, step 2 is to calculate the molar mass of the empirical formula. So let's calculate the molar mass of the empirical formula. The molar mass of this empirical formula is equals to carbon, relative atomic mass of carbon, which is 12, times, 1 is there, it's just not written there, right? Times 1 plus relative atomic mass of hydrogen, which is 1. Relative atomic mass of hydrogen is 1 times 2 plus relative atomic mass of oxygen 16 times 1. So adding this up together, 12 plus 2 plus 16 is equals to 20, right? So this is equals to 20. Sorry, this is equals to 30. Okay, so this is the molar mass of the empirical formula. The next step is divide the compound's molar mass by the empirical formula's molar mass to find the multiplier. So they gave us the molar mass of the compound to be 180. They said we should divide it by the molar mass of the empirical formula, which is 30. So this is equals to 6, right? Now, the next step, the next step is to multiply the empirical formula by this number. So now we are going to multiply the empirical formula by this number, CH2O, okay, times 6. This will become 1 is there, 1 times 6, okay, this times 6, and here 1 times 6. That will be C6H12O6. So this will be the molecular formula of the compound that we calculated its empirical formula from the previous question. Okay. Now, having talked about how to calculate the empirical formula and the molecular formula of a compound, the next thing we will be talking about is some basic laws in chemistry, law of chemical combinations. And the first of them is law of definite proportion, which states that the given compound always contain the same elements in the same proportion by mass. Okay, and the chemical formula usually reflects this fixed ratio. What this simply stand for is this law stands for is that when you get water from whatever source you get water from, either from the neutralization of acid with base, or whether you get it from nature, from seawater by this by distillation, the chemical formula is usually the same, and it usually portrays the definite proportion in which they combine. Okay, whether you get it from seawater or you get it from acid-base neutralization, it's usually combined in ratio 2 to 1. Okay, example, they say every molecule of water contains two hydrogen atoms and one oxygen atom. That's how it's usually be, irrespective of where the water is gotten from. Okay, that's just what this law of definite proportion, that's what it is talking about. Okay, now another example is carbon dioxide. Wherever you get carbon dioxide from, whether from the air or you got it from the decomposition of calcium bicarbonate, whether you got it from air or you get it from calcium carbonate, wherever you got it from, it's usually combined in a fixed ratio. Okay, one carbon atom usually combined with two carbon of oxygen. Okay, the second law we'll be talking about is law of multiple proportions, which states that when two elements combine to form more than one compound, the masses of one element that combine with a fixed mass of the other are in small whole number. Okay, and the example is when carbon combine with oxygen to form either carbon monoxide or either carbon 2 oxide or carbon 4 oxide. The masses of oxygen here, they are combined with fixed mass of carbon. Okay, they are usually in small whole number ratio. Okay, if you look at this, carbon 2 oxide, 12 gram of carbon combined with 16 gram of oxygen. Okay, and this is the ratio in which they are combined. And in carbon 4 oxide, 12 gram of carbon combined with 32 gram of oxygen. Okay, in this ratio, the ratio of oxygen masses in this is 16 combined is in 16 ratio 32, which is 1 to 2, simple whole number. The same example is given in these two oxides of nitrogen. The third law of reciprocal proportion. That this is the third law we'll be talking about, and it states that when two elements A and B each combine with a fixed mass of a third element C, the ratio of the masses of A and B that combine with each other is either the same or a simple multiple of the ratio in which they combine with C. Okay, and this is an example that is given in which hydrogen combine with oxygen to form water. It also combine with sulfur to form hydrogen sulfide. Now, when oxygen and sulfur combine to form sulfur 4 oxide, the ratio in which they are combined, which is 16 to 32, is in simple whole number ratio 1 to 2. Okay, so this is what they mean by when two elements A and B, which is oxygen and sulfur, combine with a fixed mass of the third element, which is hydrogen here. Okay, the ratio of A and B, that is sulfur and oxygen that combine with each other in sulfur oxide, okay, is either the same or a simple multiple of the ratio in which they combine. Having talked about how to calculate the empirical formula and the molecular formula and the law of chemical combinations, let's go through some questions for us to test our knowledge in the lesson. If you enjoyed this video, kindly like and share, and also subscribe to my channel to encourage me to make more videos. Okay. The question number one: the compound contains 7.2 gram of carbon, 1.2 gram of hydrogen, and 9.6 gram of oxygen. What's the empirical formula of the compound? The steps, if you can recall the steps in which we use to calculate the empirical formula. Let's first of all write out the elements that is involved: carbon, hydrogen, and the oxygen. I told you that the question can come in two forms. You can be given the percentage conversion of each of the elements, and you can be given the mass. In this question now, you are given the mass. The first thing is to calculate the mole of the mass, which is 7.2 divided by 12, 1.2 divided by 1, and 9.6 divided by 16. These are the relative atomic mass. Okay, and if we evaluate this, let's use our calculator. 7.2 divided by 1 divided by 12 is equals to 0.6. This one is 0.6. 1.2 divided by 1, which is 1.2, and 9.6 divided by 16. 9.6 divided by 16, 0.6. Okay. The next thing is to divide it by the smallest number. Divided by 0.6 divided by 0.6. This is 1, this is 2, and this is 1. So this is in CH2O. Okay. So the empirical formula of this compound is CH2O. Okay. Next question. The compound has a molar mass of 180 gram per mole and an empirical formula of CH2O. What is its molecular formula? To calculate the molecular formula of the compound, which is CH2O, the first thing we need to do is to calculate the molar mass of the empirical formula, which is 12 times 1 plus 2 plus 1 times 2 plus 16 times 1, which is equals to, this is 12. 14, which is equals to 30. Okay. Then the next thing is to divide the molar mass by the molar mass of the empirical formula. The molar mass of the compound divided by the molar mass of the empirical formula, which is equals to 6. Okay. And they said the empirical formula is CH2O. Okay. You can see this is similar to the question we did. I believe you'll be able to do it by yourself, right? So the molecular formula is C6H12O6. Okay, which is C. Next question: what is the ratio of carbon to hydrogen in the molecular formula? What you just need to do here is to divide it to up to the simplest ratio that it can be. If we say we divide this one by 4, which is 1, and divide this one by 4, this one is going to give us 2.5, and that is not allowed in a chemical formula. Okay, the ratio must be in whole number. So we are going to divide this one by 2 and divide this one by 2. That will be C2H5. Okay, that is 2 ratio 5. The answer is B. Okay, the next question: a compound contains this and the smaller mass is this. What is the molecular formula? I believe you should be able to do this. You can attempt the question and write your answer in the comment section below. Let's open up discussion so that we can learn more. Okay, the empirical formula of a compound is this. Its molar mass is this. What is the molecular formula? I believe you should be able to do this. Which of the following best describes the difference between empirical and molecular formulas? A. Empirical formula are for gases. Molecular formula are for solids. That is not correct. It's applied to all uh, chemical formula. B. Empirical formulas show ratios. Molecular mass show actual count. I believe this is correct. Empirical formulas are always more complex. That is not correct. There is no difference. Oh, that is not correct. I think the correct answer is B. What's the empirical formula of a compound that contains this of either this of calcium, this of oxygen, and this of hydrogen? I believe you should be able to do this. Attempt this question and write your answer in the comment section below. Okay. So I'll leave the remaining question for you to attempt. You can go through the question as I'm scrolling. You can pause. Okay, and attempt the question. Write your answer in the section below. If you enjoyed this video, like, share, and subscribe. Okay, so that you'll be up to date on my videos. So these are the questions, likely question that can come in exam. Okay. Thank you for listening, but don't forget before you leave, like this video, share it for others to benefit, and subscribe to my channel to encourage me to make more videos. Thank you very much. I wish you the best. Bye bye.